The morning of August 3rd, 1943. The humid air hung thick over a captured Japanese pillbox on New Georgia Island in the Solomon Archipelago. Inside the reinforced concrete structure, Lieutenant Takeshi Yamamoto of the Imperial Japanese Army's Intelligence Section knelt beside a peculiar American weapon. His hands trembled slightly as he examined the heavy machine gun, its barrel still warm from the engagement that had claimed its previous owners. Preparing and narrating this type of story took us long efforts and hard work, so if you are enjoying the story, please consider subscribing to our channel. Around him, 4 of Japan's most experienced weapons analysts leaned closer, their faces etched with a mixture of professional curiosity and something else, something that resembled concern. The weapon before them was an M2 Browning, serial number 47328, pulled from the wreckage of an American defensive position overrun 3 days earlier. For months, Imperial intelligence had been receiving disturbing reports from the front lines, reports that defied everything Japan's military doctrine taught about sustained automatic fire. The Americans, it seemed, possessed machine guns that simply would not stop firing. While Japanese Type 92 heavy machine guns were formidable weapons, they required careful management, precise timing, and regular cooling intervals. A well-trained crew could maintain perhaps 300 rounds per minute in short, controlled bursts. Push beyond that, and the weapon would overheat, jam, or worse, suffer catastrophic barrel failure. This was simply the physics of sustained fire. Every nation's weapons engineers understood this fundamental limitation, but the Americans had somehow broken those rules. Lieutenant Yamamoto had first heard the whispers from survivors of Guadalcanal. They spoke of American positions that unleashed continuous streams of half-inch caliber rounds for minutes on end. Not the disciplined, measured bursts of professional gunners, but sustained, unrelenting walls of fire that turned jungle vegetation into splinters and Japanese assault waves into memories. At first, intelligence officers dismissed these reports as battlefield exaggeration, the kind of embellishment desperate men created to explain defeat. Then came the reports from Tarawa, from Bougainville, from New Guinea. Each battlefield told the same impossible story. The American heavy machine guns fired without pause, without overheating, without the mechanical failures that plagued every other nation's automatic weapons. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lieutenant Yamamoto carefully examined the weapon's barrel assembly. The M2 was a beast of engineering, weighing nearly 90 pounds with its tripod. Its barrel stretched 45 inches, far longer than the Japanese Type 92. The barrel itself was the key to understanding this mechanical marvel. Unlike Japanese machine guns that relied on water cooling or required frequent barrel changes, the M2's heavy barrel was designed to dissipate heat through sheer mass and surface area. The Americans called it the M2HB, the heavy barrel variant. The designation was almost humble given what the barrel accomplished. Manufactured from high-grade steel alloy and carefully machined to tolerances that Japanese factories, increasingly starved of quality materials by 1943, could barely achieve, the barrel represented a triumph of industrial engineering. Each barrel was rated to fire several thousand rounds before requiring replacement, a figure that seemed almost fantastical to Japanese analysts. Outside the pillbox, the tropical sun climbed higher, sending shafts of light through shell holes in the concrete. Yamamoto's team had been studying captured American weapons for 6 months now, trying to understand the technological gap that had opened between Japan and the United States. What they had discovered was sobering. The M2 Browning was not simply a machine gun. It was the embodiment of American industrial philosophy. The weapon fed from a disintegrating link belt, allowing for continuous ammunition supply without the fabric belts that could swell in humid Pacific conditions. It operated on a short recoil principle, where the bolt and barrel remained locked together for the first fraction of a second after firing, using that recoil energy to cycle the action reliably. The trigger group was beautifully simple, robust enough to function caked in mud or sand. Every component spoke to a design philosophy that prioritized reliability over complexity, but it was the ammunition that truly revealed the gap between the two nations' industrial capabilities. The 50 caliber Browning machine gun cartridge, known to every American soldier simply as 50 BMG, was a masterpiece of ballistic engineering. Weighing over 700 grains, the bullet left the muzzle at 2,800 feet per second. At 600 yards, it could still punch through 3/4 of an inch of hardened steel armor plate. The armor-piercing incendiary variant, with its tungsten core, could devastate Japanese light tanks and fortifications with ease. Yamamoto's colleague, Captain Kenji Sato, a pre-war engineer from Mitsubishi Heavy Industries, ran his fingers along the gun's receiver. "The machining is extraordinary," he murmured in Japanese. "Look at the tolerances here. Every surface is precisely finished. There is no wasted material, no excess weight, yet the structure is overbuilt for the pressures it experiences. This is not the work of wartime improvisation. This design has been perfected over decades, and that was the heart of the matter." While Japan had entered the war with a military that emphasized spirit, discipline, and the warrior's resolve, America had entered with machines. Machines designed by men like John Moses Browning, whose genius for firearms design was matched only by America's capacity to manufacture his creations by the tens of thousands. The M2 Browning had first appeared in 1933, nearly a decade before Pearl Harbor. By the time Japan struck in December 1941, American factories were already producing them at a rate that would have seemed impossible to Japanese industry. Colt's patent firearms company led the way, but by 1942, a constellation of American manufacturers had joined the effort. General Motors divisions, including Frigidaire and AC Sparkplug, applied their automotive mass production expertise to weapons manufacturing. Saginaw Steering Gear, Wayne Pump Company, High Standard, Savage Arms, Buffalo Arms Corporation. The names read like a directory of American industrial might. Each factory contributed thousands of weapons, all built to exacting specifications that ensured every part was interchangeable. This interchangeability was itself a revelation to Japanese technicians. A barrel from a Colt-manufactured M2 could be installed on a receiver made by Frigidaire. Bolt assemblies, trigger groups, feed mechanisms, all were standardized to dimensions measured in thousandths of an inch. If a component failed in combat, American armorers simply swapped in a new one, no fitting required, no modification necessary. The weapon was back in action within minutes. Lieutenant Yamamoto had seen Japanese weapons manufacturing firsthand. He knew the reality of their production methods. Skilled craftsmen carefully fitting each piece, making subtle adjustments to ensure proper function. It was quality work, certainly, but it was slow. And as the war progressed, as Allied submarines strangled Japan's supply lines and American bombers began reaching the home islands, that slow, careful craftsmanship became an impossible luxury. The Americans, meanwhile, had built an escapement industrial system that treated precision as a manufacturing problem to be solved with better machines, tighter quality control, and standardized processes. Their factories didn't require master craftsmen for every weapon. They required trained workers, clear specifications, and machinery capable of holding tolerances. The result was weapons that came off the production line by the thousands, each one functionally identical to the last. Captain Sato was examining the weapon's feed mechanism, the intricate system that drew ammunition from the belt and positioned each round for firing. In a Japanese machine gun, this mechanism might require periodic adjustment, careful maintenance, and experienced hands to keep functioning. The M2's feed system simply worked. Its design accounted for dirt, for moisture, for the inevitable wear of combat use. Springs were sized with generous safety margins. Moving parts were hardened against wear. Even the ammunition belt itself was engineered for reliability. The disintegrating link belt was a small masterpiece of design thinking. Each cartridge sat in its own metal link, held securely until the moment of feeding. As the round was stripped from the belt and chambered, the link fell away, ejected from the weapon. No fabric to rot in tropical humidity, no belt to carefully reload under fire. American ammunition bearers simply clipped new sections of belt together, creating continuous feeds limited only by how much ammunition they could carry, and they could carry a great deal. American logistics, Yamamoto had learned, were as formidable as American weapons. While Japanese soldiers often fought on reduced rations, sometimes going days without adequate food, American troops had supply lines that seemed limitless. Ammunition arrived by the crate, by the pallet, by the shipload. A single M2 Browning position might have 5,000 rounds of ammunition immediately available, with more just a radio call away. This abundance fundamentally changed how American forces employed their heavy machine guns. Japanese doctrine emphasized the machine gun as a precision weapon, firing carefully aimed bursts to conserve ammunition and prevent overheating. American doctrine embraced the M2's capabilities, using it for sustained suppressive fire that kept enemy forces pinned while infantry maneuvered. American gunners could afford to fire 200, 300, even 500 rounds to suppress a single position. The result was a kind of firepower that Japanese forces had never encountered before. During the Guadalcanal campaign, Marines defending Henderson Field had demonstrated the weapon's capability during Japanese night assaults. In one documented engagement, a single M2 position fired over 3,000 rounds during a 6-hour battle, changing barrels twice but never ceasing fire for more than the minute required to swap the barrel and adjust headspace. The gun never jammed, never failed, just methodically consumed ammunition and Japanese assault waves with equal efficiency. Lieutenant Yamamoto stood, stretching his cramped legs. Through the pillbox's firing slit, he could see American positions in the distance, already rebuilt and reinforced after the previous battle. Somewhere in those positions, more M2 Brownings waited, each one backed by mountains of ammunition and maintained by soldiers who understood that their weapons' reliability was not luck or divine favor. It was engineering. The truth was becoming undeniable. Japan had entered this war believing that spirit could triumph over material advantage, that discipline and sacrifice would overcome American industrial capacity. But spirit could not stop a half-inch bullet traveling at 2,800 feet per second. Discipline could not charge through sustained machine gun fire that turned the very air into a wall of metal. And sacrifice, however noble, could not change the fundamental equation of modern warfare. The Americans had built a machine gun that embodied their entire philosophy of war. It was not elegant. It was not a weapon that required a master's touch to operate. It was simply, ruthlessly effective. A soldier with modest training could operate it. A supply system could keep it fed with ammunition. An industrial base could produce it faster than combat losses could deplete it. And once in position, it could fire until either the ammunition ran out or the war ended. Testing at Aberdeen Proving Ground in Maryland, Yamamoto had learned from captured documents, had demonstrated capabilities that seemed almost absurd. Engineers had fired an M2 continuously until the barrel glowed cherry red from heat. The weapon continued to function. They had subjected it to sand, mud, and salt water, then fired it without cleaning. It still worked. In one endurance test that had become legendary among American ordnance officers, they had fired a single M2 for extended periods over several days, finally stopping after 13,200 rounds had passed through the barrel. The weapon had experienced no catastrophic failures, no breakdowns that prevented continued operation. The barrel had worn, certainly, and would need replacement, but it had not burst, had not seized, had simply consumed 13,000 rounds and continued to function. To Japanese engineers familiar with machine guns that required careful management after a few hundred rounds, such endurance was almost incomprehensible. This was the weapon that American forces deployed by the tens of thousands across the Pacific Theater, mounted on tripods in defensive positions, bolted to half-tracks and jeeps for mobile firepower, installed in aircraft from fighters to bombers, where the air-cooled AN/M2 variant achieved even higher rates of fire, cooled by the slipstream of flight. Everywhere American forces went, the M2 went with them, and everywhere it went, it fundamentally altered the battlefield calculus. Captain Sato, carefully disassembled the trigger group, laying each component on a clean cloth. Each piece was precision manufactured, hardened, and finished to a degree that required expensive machinery and skilled oversight. Yet, somehow, Americans were producing these weapons at rates that suggested precision manufacturing had become routine for them. It was not just the weapons themselves, it was the system that produced them. The factories, the workers, the quality control processes, the logistics networks that moved raw materials in and finished weapons out. Lieutenant Yamamoto made notes in his report book. His superiors needed to understand what they faced. This was not simply superior firepower, it was a fundamental difference in industrial capacity and design philosophy. The Americans had created weapons that ordinary soldiers could operate at maximum effectiveness, backed by supply systems that kept them fed with ammunition. Japanese doctrine, built around the assumption that both sides faced similar material constraints, was simply obsolete when facing an enemy for whom material constraints barely existed. The afternoon sun was sinking toward the horizon when Yamamoto's team finally completed their initial examination. They had documented every specification they could measure, photographed every significant component, and begun the process of complete disassembly to understand the weapon's internals. Tomorrow, they would attempt to fire it, to experience firsthand what so many Japanese soldiers had experienced from the wrong end, to feel the weapon's sustained fire capability, its brutal reliability, its mechanical indifference to the human considerations that limited other weapons. But Yamamoto already knew what they would find. The M2 Browning would work exactly as designed, as engineered, as intended by men who had thought deeply about the problem of sustained automatic fire and solved it with better materials, smarter design, and an industrial base capable of turning design into reality at scale. It would fire until its ammunition was exhausted or until someone chose to stop it. And when American forces came, as they inevitably would, those M2 Brownings would be there, waiting with a patience that only machines possessed. The testing began 3 days later, on August 6, 1943. Lieutenant Yamamoto's team had requisitioned a secure firing range inland from the coast, far enough from American positions to avoid drawing unwanted attention. They had also managed to procure several hundred rounds of captured .50 caliber ammunition, enough to conduct meaningful tests of the weapon's capabilities. The M2 Browning sat mounted on its tripod, positioned to fire down a cleared lane into a hillside backstop. Captain Sato adjusted the weapon's elevation, familiarizing himself with the traverse and elevation mechanism. The controls were intuitive, designed for rapid adjustment even under combat stress. Everything about the weapon spoke to thoughtful engineering refined through years of development. Yamamoto stood to the side with a stopwatch and notepad, ready to document rate of fire, any malfunctions, and the weapon's behavior under sustained use. 2 other analysts prepared to observe barrel temperature and mechanical function. They had studied the captured American technical manuals, translated laboriously by intelligence staff who understood both English and military terminology. The manuals themselves were revelations, clear and comprehensive guides that assumed the reader was an intelligent soldier, not a trained armorer. Captain Sato charged the weapon, pulling the bolt handle back and releasing it with a metallic clack. He settled behind the gun, gripping the spade grips that served as the weapon's firing controls. His thumb found the butterfly trigger between the grips. He looked back at Yamamoto, who nodded. The first burst tore through the morning air with a sound that was both familiar and alien. The deep, rhythmic hammering of .50 caliber fire, but sustained in a way that Japanese machine guns simply could not match. Sato held the trigger for 5 seconds, sending approximately 40 rounds downrange. The weapon functioned flawlessly, each round feeding smoothly from the belt, firing, and ejecting. The spent brass clattered to the ground in a growing pile. They fired in bursts initially, conservative 10 to 15 round strings separated by brief pauses. The weapon's behavior was consistent, predictable. The recoil was substantial but manageable, the heavy tripod and the gun's own weight absorbing much of the force. After 50 rounds, Yamamoto called a halt to inspect the weapon. It was barely warm, No sign of stress or malfunction. They resumed firing. By the time they had expended 200 rounds, the pattern was clear. The M2 simply absorbed punishment that would have degraded a Japanese machine gun's performance. The barrel was heating, certainly, but nowhere near the critical temperatures that would cause concerns. Sato increased the burst lengths, firing 20, 30, 40 rounds at a time. The gun maintained its cyclic rate of approximately 500 rounds per minute, never wavering, never hesitating. Preparing and narrating this type of story took us long efforts and hard work. So, if you are enjoying the story, please consider subscribing to our channel. At 300 rounds, they paused for a longer inspection. The barrel was hot to the touch, but the weapon showed no signs of mechanical stress. No parts were working loose. No unusual wear patterns appeared on any surfaces. The feed mechanism continued to strip rounds from the belt with mechanical precision. Yamamoto made careful notes. This level of sustained fire would have required a barrel change on most Japanese weapons, or at minimum, a lengthy cooling period. They resumed firing, and now Sato began to truly test the weapon's limits. He fired a continuous burst of 100 rounds, the gun hammering away for roughly 12 seconds without interruption. The sound echoed across the valley, a sustained roar that surely carried for miles. When the burst ended, the barrel glowed with heat shimmer. But the weapon had not faltered once. Every round had fired, every empty link had ejected. The machine continued its work with industrial indifference. Captain Sato looked back at his colleagues, and in his eyes was something that Yamamoto recognized immediately. It was not admiration, exactly. It was understanding. Understanding of what Japanese soldiers faced every time they advanced against American positions. This weapon, multiplied by dozens or hundreds across a defensive line, backed by effectively unlimited ammunition, represented firepower on a scale that traditional infantry tactics simply could not overcome. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The testing continued for another hour. They fired the weapon in various modes, simulating different combat scenarios: short bursts for precision work, extended bursts for suppression. They even attempted to induce malfunctions by deliberately mishandling the ammunition belt, allowing it to twist and bind. The M2 simply adjusted, its feed mechanism powerful enough to straighten the belt and continue feeding. Only when they severely kinked the belt, far beyond what would occur in any realistic scenario, did the weapon finally stop. And even then, a simple correction of the belt and a quick charge of the action brought it back to full function. By the time they exhausted their ammunition supply, having fired just over 400 rounds, the weapon was hot but fully functional. The barrel would need time to cool before safe handling, but there was no doubt that with proper barrel management and adequate ammunition, this gun could sustain fire for extended periods that would be tactically decisive. And the Americans, Yamamoto knew, had solved the barrel management problem as well. The quick-change barrel system, documented in the captured manuals, allowed trained crew to swap a hot barrel for a cool one in under 2 minutes. With 2 or 3 spare barrels available, an M2 position could maintain fire indefinitely, limited only by ammunition supply. And ammunition, for the Americans, was never in short supply. Their logistics doctrine assumed that machine guns would fire thousands of rounds in an engagement. Japanese doctrine hoped that a few hundred rounds might be available. The implications were staggering. During the Guadalcanal campaign, American forces had defended Henderson Field with machine gun positions that sometimes fired 5,000 rounds in a single night as Japanese forces launched repeated assaults. Those M2 positions, properly supplied and maintained, had broken attack after attack simply by maintaining continuous fire, not through superior tactics or fighting spirit, but through mechanical reliability and material abundance. Lieutenant Yamamoto began drafting his report that evening, sitting in the stifling heat of a field tent, a kerosene lamp providing dim illumination. He chose his words carefully. The Imperial Japanese Army was not accustomed to admitting technological inferiority, especially not to Western powers whom pre-war propaganda had dismissed as soft and decadent. But the truth could not be avoided. The Americans possessed a significant advantage in automatic weapons technology, and more importantly, in the industrial capacity to deploy that advantage across every battlefield. The M2 Browning, he wrote, represents a fundamental shift in the nature of automatic weapons, where our own doctrine emphasizes the machine gun as a precision tool requiring careful management. American doctrine treats it as an area weapon capable of sustained suppressive fire. This difference reflects not merely design philosophy, but industrial capacity. The weapon's reliability under sustained fire is exceptional, far exceeding our own heavy machine guns. More concerning is the apparent ease with which American forces supply ammunition to these weapons. We have captured positions where thousands of rounds of .50 caliber ammunition were stockpiled for single guns. He paused, considering his next words carefully. The Americans' industrial advantage extends beyond the weapons themselves to every aspect of their employment. Manufacturing precision ensures reliability. Logistics abundance enables sustained operations. Design philosophy emphasizes ease of use over requirement for specialized skills. The result is a weapons system that can be effectively operated by soldiers of average training, supplied by a logistics network that treats ammunition as abundant and maintained with simple procedures and interchangeable parts. The report would travel up the chain of command, Yamamoto knew, where it would be read by officers who might not want to accept its implications, but those implications were unavoidable. Japan was fighting a war of attrition against an enemy whose industrial capacity was not merely superior, but operated on entirely different principles. Where Japanese factories carefully crafted weapons, American factories mass-produced them. Where Japanese logistics struggled to supply enough ammunition for careful, measured fire, American logistics assumed unlimited expenditure. Captain Sato joined him in the tent, carrying 2 cups of weak tea. They sat in silence for a moment, listening to the distant sounds of the jungle night. Finally, Sato spoke. "We cannot build weapons like this, not in the numbers they produce them, not with our current industrial base." Yamamoto nodded slowly. "No, we cannot. But the High Command needs to understand what we face. Our tactics, our doctrine, everything assumes rough parity and firepower. That assumption is false. When our soldiers assault American positions, they are not facing equivalent forces. They are facing industrial warfare on a scale we simply cannot match." The conversation touched on something neither man wanted to fully articulate. The war, begun with such confidence in Japan's martial spirit and fighting élan, was revealing itself to be a contest of industrial production, logistics capacity, and technological innovation. In each of these areas, the United States possessed overwhelming advantages. The M2 Browning was merely one symptom of a larger reality. Over the following months, as Yamamoto's reports circulated through intelligence channels, similar assessments arrived from other theaters. From Burma, analysts reported that British and American forces were employing M2 Brownings to devastating effect against Japanese positions. From New Guinea, field commanders described American defensive positions so thoroughly interlocked with machine gun fire that assault tactics simply could not penetrate them. From the Central Pacific, where American forces had begun their island-hopping campaign, reports detailed the use of M2s in aircraft, on landing craft, and in ground positions, creating overlapping fields of fire that turned beaches into killing zones. The weapon appeared everywhere, adapted to every role. On American patrol torpedo boats, quad-mounted M2s provided close-range firepower against Japanese barges and coastal craft. On half-tracks and armored vehicles, the M2 served as both anti-personnel and anti-aircraft armament. In defensive positions, carefully sighted M2s anchored entire defensive lines, their long range and penetrating power allowing them to engage targets well beyond rifle range. And in American aircraft, the lighter AN, M2 variant armed everything from fighters to heavy bombers. Japanese pilots who survived encounters with American fighters reported the devastating effect of concentrated .50 caliber fire. A P-47 Thunderbolt carried 8 M2S in its wings. A 2-second burst put nearly 300 rounds into the air. Against Japanese aircraft, which generally lacked armor protection and self-sealing fuel tanks, such firepower was catastrophic. American pilots simply had to put rounds on target, and the combination of rate of fire and projectile weight did the rest. The bomber formations that began appearing over Japanese positions presented an even more sobering picture. A B-17 Flying Fortress carried 1350 caliber machine guns. A formation of 12 B-17s represented 156 heavy machine guns, all capable of sustained fire. Japanese fighter pilots who attempted to intercept these formations faced a literally wall of bullets. Some pilots reported that the tracers were so numerous they looked like streams of fire connecting the bombers to any approaching fighter. Lieutenant Yamamoto received updates from various sources throughout late 1943 and into 1944. Each report added detail to the picture of American firepower dominance. At Tarawa, Marine Corps M2 positions had held off repeated Japanese counterattacks, the guns firing continuously for hours. At Bougainville, Army units had used M2S to such effect that Japanese commanders abandoned frontal assaults entirely, seeking to infiltrate through the jungle instead. At Saipan, the Marines would employ M2S mounted on Amtracs and tanks, bringing mobile heavy firepower directly into assault waves. The weapon's versatility was almost as significant as its reliability. American forces had adapted the basic M2 design to dozens of specific applications. The M45 quad mount placed 4 M2S on a single powered turret, creating a devastating anti-aircraft weapon that was equally effective against ground targets. The naval versions, designated differently but functionally identical, armed everything from landing craft to battleships. Special lightweight versions for aircraft achieved even higher rates of fire, cooled by the aircraft's slipstream, to the point where they could sustain fire rates approaching 1,000 rounds per minute. But it was the ground version, the M2HB, that most concerned Japanese infantry commanders. This was the weapon their soldiers would face in every engagement, the weapon that defined the character of American defensive firepower. And increasingly, as American forces shifted to offensive operations, it became the weapon that supported those offensives, providing suppressive fire that allowed infantry to maneuver while enemy positions were pinned by sustained machine gun fire. By mid-1944, Lieutenant Yamamoto had been reassigned to a planning position, where his technical expertise was applied to the grim task of developing tactics to counter American firepower advantages. It was, he quickly realized, an almost impossible assignment. How does one counter an enemy who can afford to fire 5 rounds for every one you fire? Who possesses weapons that function reliably under conditions that would disable your own? Who treats ammunition as expendable and machine guns as reliable tools rather than temperamental weapons requiring constant care? The answer, such as it was, involved accepting casualties that would have been unthinkable in earlier Japanese military thinking. Attacks would need to be conducted at night, when American firepower advantages were somewhat reduced. Infiltration tactics rather than frontal assaults. Exploitation of any gap in the American lines before machine guns could be repositioned. Essentially, Japanese tactics had to evolve to avoid American strengths because directly confronting those strengths was simply suicidal. The Battle of Iwo Jima in February 1945 would demonstrate both the effectiveness of M2 Brownings and the tragic determination of Japanese defenders forced to face them. American Marines landed with extensive M2 support, the guns mounted on amphibious vehicles, emplaced on the beach, and brought forward as positions were secured. Japanese defenders, fighting from prepared positions, inflicted terrible casualties on the attackers, but they could not stop the advance, because American firepower, centered on those reliable, ruthless M2 Brownings, simply overwhelmed defensive positions through sustained fire. One Marine, Corporal Tony Stein, would earn the Medal of Honor on Iwo Jima using a modified aircraft machine gun he called the Stinger. It was essentially an AN M2 adapted for ground use, demonstrating yet again American ingenuity in applying firepower to tactical problems. Stein used his weapon to suppress Japanese positions, make multiple trips back for ammunition, and provide covering fire for his squad's advance. The weapon fired without failure throughout his actions, consuming thousands of rounds and enabling his unit to advance across terrain that would otherwise have been impassable. Lieutenant Yamamoto, by that time stationed in Japan, and watching the American bombing campaign reduce Japanese cities to ash, read the reports from Iwo Jima with a sense of inevitability. The M2 Browning had become symbolic of everything that had gone wrong with Japanese war planning. They had assumed that fighting spirit could overcome material disadvantage. They had believed that disciplined soldiers, armed with adequate weapons, could defeat an enemy possessing superior equipment. They had convinced themselves that American industrial might was somehow less significant than Japanese martial tradition. All of those assumptions had proven catastrophically false. The M2 Browning was not just a machine gun. It was proof that modern warfare was industrial warfare, that production capacity mattered more than warrior spirit, that reliable weapons in vast quantities trumped superior training with limited equipment. The gun that could fire 13,000 rounds without catastrophic failure was the gun that won the war, because it represented a nation that could afford to fire 13,000 rounds, that could supply 13,000 rounds, that could manufacture machines capable of such sustained performance. In his final report, written in the war's closing months, Yamamoto was brutally honest. The M2 Browning heavy machine gun represents American industrial and engineering capabilities that we cannot match with our current resources. More significantly, it represents a philosophy of warfare that treats material abundance as a tactical advantage to be exploited. Where we conserve ammunition and fire in careful bursts, the Americans fire continuously and resupply freely. Where we view mechanical reliability as a goal requiring constant maintenance, the Americans design reliability into the weapon itself. Where we accept that sustained fire will degrade weapon performance, the Americans build weapons that sustain fire as their primary function. He continued, "The lesson for future Japanese defense planning is clear. We cannot defeat an enemy who possesses such overwhelming advantages in both quality and quantity of weapons. Our soldiers, however brave and well-trained, cannot charge through walls of fire produced by machines that do not tire, do not miss, and do not fail. Any future conflict must account for this reality. Spirit alone is insufficient. Sacrifice without adequate weapons is merely waste. Industrial capacity, technological innovation, and logistics abundance are the true determinants of modern warfare." The report was filed in August 1945, just days before the atomic bombs fell on Hiroshima and Nagasaki. It was never widely distributed, lost in the chaos of Japan's surrender and occupation. But Lieutenant Yamamoto had documented the truth that many Japanese officers had learned in blood across the Pacific. The Americans had not won because they were better soldiers. They had won because they were better armed, better supplied, and backed by an industrial system that treated weapons, production as a solvable engineering problem rather than an artisanal craft. The M2 Browning would go on to serve for decades after World War II ended. It fought in Korea, where it once again proved its worth in both offensive and defensive roles. It served in Vietnam, where its long range and penetrating power remained valuable despite the close-quarters jungle fighting. It would eventually become the longest-serving machine gun in American military history, with some weapons remaining in active service for over 90 years. In 2015, the Army finally retired a particular M2 that had been manufactured in 1933, a weapon that had literally served longer than most soldiers who fired it had been alive. That longevity was no accident. The M2's design, refined over years of development and proven in the crucible of World War II, represented engineering principles that remained valid across generations of warfare. Reliability, sustainability, manufacturability. These were not glamorous qualities, but they were the qualities that mattered when the shooting started. A weapon that always worked was worth more than a weapon that worked brilliantly but occasionally failed. For the Japanese soldiers who faced M2 Brownings across the Pacific, That reliability was terrifying. They charged positions knowing that the American guns would not jam at a critical moment, would not overheat and fail, would not run out of ammunition because logistics had broken down. They faced a kind of mechanical certainty that removed hope from desperate assaults. The gun would fire, the bullets would come. The only variable was whether they would survive the crossing. Captain Sato, who survived the war and returned to work in Japan's reconstruction, would later write in his memoirs about that day testing the captured M2. "We understood, in that moment, that we were fighting not just American soldiers, but American industry. Every round that gun fired represented factory, production, quality control, logistics networks, and design philosophy. We could match their soldiers' courage, we could not match their industrial capacity. That was the lesson of the M2 Browning. It was a lesson learned at tremendous cost. Japanese casualties in the Pacific Theater exceeded 2 million, many of them falling to American firepower they simply could not overcome. The M2 Browning was only one weapon among many that contributed to that toll, but it was perhaps the most symbolic. It represented the American way of war: overwhelming firepower, reliable equipment, and logistical abundance applied with methodical efficiency. The testing session on New Georgia Island in August 1943 had revealed a truth that Japanese military planners had been reluctant to accept. Modern warfare had moved beyond the realm where traditional military virtues could compensate for industrial disadvantage. The nation that could produce weapons like the M2 Browning by the tens of thousands, supply them with millions of rounds of ammunition, and maintain them in combat conditions across the globe, was the nation that would win. Japan, for all its martial tradition and fighting spirit, was not that nation. And so the war ground on, with Japanese forces fighting increasingly desperate defensive battles against an enemy whose material advantages only grew larger. The M2 Brownings continued to fire, consuming ammunition at rates that would have bankrupted Japanese logistics, breaking attack after attack with mechanical indifference. By the war's end, American forces had fired billions of rounds of .50 caliber ammunition, a figure that represented not just firepower, but industrial triumph. Lieutenant Yamamoto survived the war, watched the occupation, and eventually found work as a technical translator, helping Japanese companies understand American industrial methods. He never forgot that morning testing the M2, never forgot the moment he realized that Japan had been fighting a war it could not win, against an enemy whose advantages were not tactical or strategic but fundamental. The Americans had built better weapons and possessed the industrial base to deploy them everywhere they fought. The M2 Browning that Yamamoto's team tested was eventually recovered by advancing American forces and returned to service. It may have fought at Okinawa, may have served in occupation duty, may have been one of the thousands of M2s that continued serving through Korea and Vietnam and beyond. The serial number was recorded in Yamamoto's notes, but whether that specific weapon survived is unknown. What matters is that it was one of over 2 million M2s, produced during and after World War II, each one a testament to American industrial might. The gun that could fire 13,200 rounds without jamming was not just a technical achievement. It was a symbol of the kind of total industrial war that characterized the 20th century. Wars would no longer be won primarily by superior tactics or fighting spirit, though those remained important. They would be won by nations that could outproduce, outsupply, and out-engineer their enemies. The M2 Browning proved that lesson in the Pacific, one devastating burst at a time, across thousands of engagements on islands whose names became synonymous with the brutal arithmetic of industrial warfare. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.